All right, this is chapter 4, number 60. This is the one where the person's pushing on the block. Before I get into this problem, just a couple of quick things for the help with the visual. If we imagine that this is the book up against the wall, it is possible to push on this at an angle such that it doesn't slide down, okay, so that it doesn't have to move. It's always good to have a visual in the real world when you're doing these problems. There's a decent picture in the book that helps as well. Let's take a look now at part A. And part A asks, what minimum force is required to prevent the block from sliding down the wall? So we're trying to keep the block from sliding down the wall and the minimum force that we have to apply. Well, in that scenario I just showed you, if we want to provide the least amount of force, we want friction to provide the most. So when I draw my free body diagram, it will be force of friction, static, max. And that's where I'm going to start, is with the free body diagram. So the picture's in the book. I'll add one up here as well. So there's the wall. There's our force, F. And there's an angle there of 40 degrees. So there's an angle here of 40 degrees. And this is F. Look in the book for the better picture. Free body diagram for this book that's being pushed against the wall would be our force F up and to the right, our force of weight going down, and the book's trying to slide down the wall, so friction will go up, and we already discussed that it is force of friction static max. It's the maximum value, which means we don't have to use the inequality. There's one more force, and this is the weird one the first time you see it, and that's the normal force, the perpendicular contact force due to this wall. So the wall pushes on the book to the left, and that actually is our normal force. So our normal force is in the x direction, and that happens on a couple other problems in the assignment. I think one of our openers as well, so you've seen this. The finish fling example from class that happened as well. So normal force is not always just in the y. It can be in the x, or we'll see some problems soon in the next chapter where it's in the x and y direction, where it's at an angle. Trying to find F, so I'm going to start summing forces. Oh, and they gave me a little bit more information, I think. I think they told me the mass of the book. Or they told me the weight of the block. The weight of the block is 88.9 newtons. So I know this is 88.9 newtons. And they told me mu sub s, the coefficient of static friction. And that is 0.56. 0.56. Now I'm going to go ahead and sum forces. And hopefully we'll be able to solve for F. To get what F is, I'll need both components of F so I can put it back together and get the overall force. Doesn't matter what direction you start in, I'm going to go ahead and start in the x direction. So we're going to sum the forces in the x direction equals mass times acceleration in the x. Well, good news, the book is not going anywhere, so our acceleration in the x and in the y direction will both be 0. That'll make our math life very easy. So we'll have fx minus the normal force equals 0, and I'm doing standard. Up and right is positive. So Fx is to the right, the x component of F is to the right, normal force is to the left. Let's see, it looks like we're stuck there because we don't know the normal force and we don't have Fx, so let's keep going. Let's sum the forces in the y direction. And again, the book's not going anywhere in either direction, so that's 0. In the y direction, we have three things: static max, the weight, and the y component of this force. Give myself a little bit more room here. So we'll have the normal force going to the left again, or excuse me, y direction. Y direction. We'll have Fy going up. So Fy is going up. Static max is going up. And our weight's going down. And again, here we know the weight. We don't know Fy and we don't know static friction, so it looks like we're stuck. We need to do more. So let's write down other relevant equations. Well, we're dealing with friction, so let's write down the equation for friction. In this case, friction static max, and that equals mu sub s times normal. And we know mu sub s. I still think there's not enough up here because of these components of these forces, but let's go ahead and start plugging in numbers and see where we get stuck. We might need to relate to the x to the y or do some other little trick here. Okay, so force of friction static max equals mu, which is 0.56 times the normal. Here I don't know Fy. I don't know force of friction static max beyond what's right there. Force of friction static max. The weight I do know. They said 88.9 newtons, and that equals 0. I don't know fx, and I don't know fn. Well, I can do a little bit of substitution in here, so I'm going to go ahead and do that. I'm going to put static max in from that equation over there. So I'm really kind of doing three different things here. We've got three equations, and I think I've got, I'm not sure how many unknowns I haven't counted, but we've got a bunch. Okay? So I'm going to go ahead and substitute this in right here for static max, plus 0.56 times the normal force, minus 88.89 newtons equals 0. And now let's take a look at these two equations. Normal force, there's one unknown. Fx, Fy, there's two more. So I have three equations, excuse me, the ones in the box. I have two equations, 1, 2, and how many unknowns? Fx and Fy, there's two unknowns, and the normal force, there's a third unknown. So I need more equations, and I've already used this part over here. I'm done with that. I'm already done with. I've used that, I've substituted in. So I need another equation, or I need to substitute something in. Two approaches here. I'm going to use the approach right now that most students are the most comfortable with at this point in the course, and then I'll talk about the other approach that I like to do later in the course when this stuff pops up. So what can I put in for Fx and Fy to get rid of a variable? Well, I haven't calculated components or written what that would be. So let's go ahead and think about that and do that. So here's my force F, and they gave me this angle as 40, just showing you the original picture. This is 40, back to your geometry days, if this is 40, this right here is 40. So you can get your x and y components. Your fx will be the opposite, your fy will be the adjacent. So I can write here that fx equals f sine 40 degrees. And again, it's based on this triangle right here. The x is the opposite side. Or you can do this one too if you prefer. The x will still be opposite the 40.